What if an interstellar object whirling through our solar system is actually a nuclear-powered spacecraft sent by aliens to test how humans respond?
Something unprecedented has just entered our solar system, and scientists are scrambling to make sense of it. On July 1st, 2025, astronomers detected a new interstellar visitor named 3I Atlas, an object hurtling through space at over 200,000 kilometers per hour on a path that defies easy explanation.
On the 1st of July, NASA detected a mysterious object speeding toward Earth, and some actual bona fide experts think it might not be your typical space rock, or maybe any kind of rock, or a natural phenomenon at all.
At first glance, it looks like a comet, shedding dust and ice as it races past the sun. But its trajectory, its brightness, and even the way it glows have raised questions that are far stranger than anything we've seen before. Some researchers argue it's just an exotic comet. Others, like Harvard astrophysicist Avi Loeb, suggest it could be something far more extraordinary, even a probe disguised as a natural object. And now, new analysis hints at the possibility that 3I Atlas may actually be generating its own light, a finding that would completely upend our assumptions about its size, nature, and origin. Is this a natural wonder from deep space, or the first evidence of alien technology crossing into our neighborhood? To find out, let's start with the basics of what we're really dealing with here. On July 1st, 2025, astronomers working with the Asteroid Terrestrial Impact Last Alert System, better known as ATLAS, spotted something that immediately stood out from the countless rocks and icy fragments drifting through space.
A new telescope built to track fast-moving space objects in Chile has caught a comet from beyond the solar system moving across the sky.
At first, it looked like a faint moving dot in the sky, just another entry in the growing catalog of near-Earth objects. But as the data came in, the truth hit hard. This was no ordinary asteroid or comet. Its orbit showed an eccentricity well above 1, a mathematical marker that means it isn't tied to our sun's gravity. In other words, it didn't form here, and it won't stay here. This object is an interstellar visitor cutting through our solar system at a blistering speed of over 200,000 kilometers per hour. Astronomers realized within hours that 3I Atlas was unlike anything we've tracked before. Its sheer velocity and trajectory suggested it had been traveling through deep space for millions of years before briefly crossing paths with us. For context, most asteroids we study circle the sun like predictable clockwork. This one, it's just passing through on one of the most extreme paths ever recorded. Right from the start, scientists knew they weren't just watching another rock. They were witnessing a once-in-a-lifetime event, maybe even the beginning of a mystery that could reshape how we see the universe. If the discovery itself wasn't already astonishing, what came next left astronomers baffled. When the Hubble Space Telescope turned its gaze toward 3I Atlas, the images revealed a glow that didn't quite behave the way it should. Normally, comets shine by reflecting sunlight off their icy surfaces and dusty tails. The brightness follows a predictable curve. The closer they get to the sun, the brighter they appear, and the change is relatively smooth. But 3I Atlas broke the rules. Its brightness profile was far steeper than expected, rising in a way that didn't fit the patterns of any comet we've studied before. Here's why that matters. When scientists estimate the size of an object in deep space, they usually assume that it's just bouncing sunlight back at us. Using that standard model, 3I Atlas would need to be absolutely enormous, around 20 kilometers across, to shine as brightly as it does. That would make it roughly 40 times larger than Oumuamua or Borisov, the two interstellar visitors we've seen in recent years. But this conclusion set off alarm bells because the odds of such a colossal interstellar object passing through our system are almost non-existent. That's when Harvard astrophysicist Avi Loeb, along with researcher Eric Kito, put forward a radical alternative. They suggested that 3I Atlas might not be reflecting sunlight at all. Instead, its glow could be self-generated, as if the object itself is producing light. And if that's true, then everything changes. It wouldn't need to be 20 kilometers wide. It could be just a few hundred meters across, small enough to be overlooked as ordinary, but with implications that are anything but ordinary. Think about it. The difference between a natural 20-kilometer chunk of rock and a self-illuminating object the size of a skyscraper isn't just a technical detail. So it's a paradigm shift. It forces us to ask whether we're looking at a new kind of natural phenomenon or something far stranger. What do you think? Does the light point to hidden natural physics we don't yet understand, or could it be evidence of technology? Comment below. I'm curious what you believe. Now, here's where the numbers make this story even more unsettling. If 3I Atlas truly were a 20-kilometer-wide interstellar object, the kind required to match its brightness under normal sunlight reflection, the odds of it showing up in our neighborhood are vanishingly small. Avi Loeb's calculations show that the galaxy simply doesn't have enough giant rocks drifting between stars to make this event anything close to common. In fact, the chance of stumbling across a visitor that massive is about once every 10,000 years, if not longer. That means one of two things has to be true. Either we just got spectacularly lucky, hitting cosmic lottery odds with the arrival of 3I Atlas, or the assumptions behind our size estimates are wrong. And if Loeb and Keto are right, and the object is generating its own light, the math suddenly works out much more neatly. A smaller, self-illuminating traveler would fit the probabilities far better, slipping into our solar system without requiring an impossible stroke of luck. This is why the brightness debate isn't just about numbers on a telescope readout. It directly affects how plausible each explanation is. A natural giant interstellar rock feels almost impossible. A smaller, glowing object, far more likely and far more provocative. Because if something is lighting itself up across the gulf of space, then we're forced to ask, what exactly are we looking at? And the mystery doesn't stop there. The trajectory of 3I Atlas only deepens the puzzle. As if its brightness wasn't strange enough, the path 3I Atlas is taking through our solar system has raised even more eyebrows. Unlike most interstellar objects, which arrive on random, chaotic angles, this one is traveling on a retrograde orbit, tilted only about 5 degrees from the ecliptic plane, the same flat disk where Earth and nearly all the planets circle the Sun. That kind of near-perfect alignment is not what scientists expected. The odds of this happening by random chance, roughly 0.2%. But the coincidences don't stop there. Over the next few months, 3I Atlas will swing astonishingly close to multiple major planets. It will pass within 29 million kilometers of Mars on October 3rd, reach its closest point to the Sun later that same month, and eventually come within 33 million kilometers of Jupiter. Astronomers crunch the numbers. The odds of an interstellar object randomly threading such a path, brushing past 3 major planets in a single journey, are about 1 in 20,000. And here's where things get even more suspicious. 3I Atlas reaches its closest approach to the Sun at a time when Earth will be on the exact opposite side of our star. That means during its most critical maneuver, when the object could reveal its true nature, every ground-based telescope on Earth will be blinded by solar glare. If you were designing a spacecraft to perform a reverse solar Oberth maneuver, a high-thrust braking technique that could slow you down and let you stay in the solar system, this would be the perfect moment, hidden from Earth, timed with precision, practically invisible. Now, maybe this is all just a string of cosmic coincidences, but when you stack the improbability of its size, its glow, and now its suspiciously convenient orbit, it starts to feel less like random chance and more like design. What about you? Do you see this trajectory as pure luck, or does it look a little too perfect to ignore? Drop your thoughts below. Of course, not everyone is ready to jump to extraordinary conclusions. Many astronomers argue that 3I Atlas, despite its strange quirks, still fits within the realm of a natural interstellar comet. And to be fair, there's solid evidence backing up that view. Spectroscopic readings from both Gemini South and NASA's Infrared Telescope facility show strong signatures of water ice mixed with minerals like silicates and carbon-rich compounds. These are the same building blocks we see in countless comets within our own solar system. On top of that, scientists tracking the object's dust activity measured ejection rates between 6 and 60 kilograms per second, with particle speeds anywhere from 20 to 2,000 meters per second. Those numbers sit comfortably in the range of what comets normally produce. And while skeptics point to the lack of certain gas emissions, things like cyanogen or diatomic carbon, astronomers caution patience. Right now, 3I Atlas is still far from the Sun, about the distance of Jupiter. Most comets don't start showing dramatic gas activity until they're much closer, when solar heating really kicks in. So the absence of these emissions isn't necessarily unusual. Then there's the self-illumination idea. If 3I Atlas truly were producing its own light through some nuclear or thermal process, it would need to generate around 10 gigawatts of power, the equivalent of several massive power plants running continuously. Keeping that kind of energy output alive while traveling through interstellar space for millions of years is hard to imagine unless we're talking about technology far beyond our own. So, While the alien probe hypothesis makes headlines, the simpler explanation that this is just a comet behaving in ways we don't fully understand yet remains the scientific consensus. Still, even the defenders of the natural explanation admit that 3I Atlas is strange, and with every new observation, the line between normal and extraordinary gets a little blurrier, and the real test is just ahead, because the next few months will give us the clearest look yet at what we're dealing with. The coming months are shaping up to be the make or break moment for solving the 3I Atlas mystery. As this object races closer to the Sun, astronomers are lining up some of the most powerful tools we have to uncover its true nature. At the top of the list is the James Webb Space Telescope. With its unmatched infrared vision, JWST can track the object's temperature changes, energy output, and even subtle details in its chemical makeup. If 3I Atlas is simply reflecting sunlight, Webb should see a predictable cooling profile. But if it's generating its own light or heat, the telescope could catch those anomalies in real time. A detection like that would change everything. Then there's Mars. On October 3rd, the object will pass within 29 million kilometers of the red planet, close enough that the Mars Reconnaissance Orbiter's high-rise camera may be able to snap high-resolution images. Imagine that, for the first time in human history, we could get a direct close-up of an interstellar object's surface. That alone would be historic, regardless of whether the glow turns out to be natural or artificial. But here's the frustrating part. When 3I Atlas reaches its closest point to the Sun, Earth will be on the opposite side of our star. That means ground-based telescopes here will be completely blind during the most crucial stage of its journey. Some scientists call this nothing more than bad timing. Others point out how eerily perfect the timing seems if you were trying to hide something. And beyond this single object, a new era of discovery is just beginning. The Vera C. Rubin Observatory, which has just begun operations, is expected to detect dozens of interstellar visitors every year. That will give astronomers the statistical sample they need to figure out what's truly normal and what's genuinely anomalous. If 3I Atlas is unique, it may stand out as a technological outlier. But if others like it start appearing, the universe could be telling us that these kinds of mysteries are far more common than we ever imagined. If you had the chance to point just one telescope at 3I Atlas, Hubble, JWST, or the Mars Reconnaissance Orbiter, which would you choose? Let me know in the comments. As 3I Atlas continues its journey through our solar system, we're watching one of the most fascinating cosmic events of our time unfold in real time. Whether it turns out to be a natural comet behaving in ways we've never seen before or something far more extraordinary, this visitor is already rewriting the rules. The brightness mystery, the improbable trajectory, and the looming close encounters are pushing astronomers to the edge of what we thought was possible. The next few months, from October's Mars flyby to December's approach near Earth, will be critical. Each new observation could tip the balance one way or the other. And the answer matters, because if 3I Atlas is natural, it teaches us that the galaxy is far stranger and more diverse than we imagined. But if even part of the artificial hypothesis holds true, then this would be the most significant discovery in human history, proof that we are not alone. Either way, this is the kind of science that doesn't just fill textbooks. It changes perspectives, it challenges what we believe, and it sparks new questions about our place in the universe. And now I want to hear from you. Do you think 3I Atlas is just an unusual comet, or could it be something designed? Comment your thoughts down below. I'll be reading them. And if you want to stay ahead of every twist in this story, don't forget to like this video, subscribe to the channel, and turn on notifications so you don't miss the latest discoveries about our universe. Because whatever 3I Atlas turns out to be, one thing's for sure, the cosmos still holds secrets that could change everything we think we know.